Hello, sixth graders. We are in Unit 7, our Intro to Algebra and Equations unit. Today we are looking at addition and subtraction equations, and our learning target, I can solve addition and subtraction equations. Okay, these first three lines here are for something just for you to think about. So think about what you know about the equation x plus 5 equals 8. Is it easy for you to find the value of x? Are you able to solve what x should be? However, think about how could you explain this to someone who it is not as obvious to? So if somebody couldn't just look at that equation and know the answer, how could you explain it or show to them what the answer would be? Main idea here that I want you to write down, whatever you do to one side of an equation, you must do to the other side to have the sides remain equal. So if you're adding a value to one side, you have to add it to the other side. If you are dividing on one side, you have to divide on the other to keep it equal. Vocab word here that you should have written down is, inverse operations. So write this definition, or write this stuff down. They help solve the unknown variable. Okay, they help you figure out what the variable will be. Note this part should also be written down. The inverse operation of addition is subtraction. And then going the other way, the inverse operation of subtraction is also addition. And then know that the inverse operation of division is multiplication, and the inverse operation of multiplication is division. So inverse operations. Well, inverse means opposite. Operations, addition, subtraction, multiplication, division. So it's the opposite operation. And those things will be helping us to solve our equations today. Okay, these steps should be written down in your notebook. These are what we use every time we are solving one-step equations. No matter how easy or simple it may be, we're going to follow these steps every time. First, you write the equation, whatever the original equation might be. Then you're going to draw what I call train tracks. I'm just going to kind of show you a quick example. So if we had that x plus 5 equals 8, we wrote the equation. The train tracks, they go right down the equal sign like this. Then we use the inverse operation to isolate the variable. So inverse operation, the opposite. Isolate the variable means to get the variable by itself. So we want to get the variable all alone. We don't want anything else to be on that side. And we get that by using the inverse operation. Then you solve for the variable, and then you check your solution. We check by plugging our answer back into this original equation and see if we get the right answer back. Okay, so let's start going through one-step addition equations. So looking at our first one here, I'm going to zoom in. Our original equation, x plus 6 equals 4. So step 1, write down the equation. The next step was to draw the train tracks, so I draw them right down. So that's showing that whatever I do on one side of the train tracks, I'm then going to show doing it on the other side in order to keep it balanced. Think of a scale. You have to put stuff on each side to keep it balanced. Next step is the inverse operation. So we have x plus 6. The inverse of addition is to do subtraction. So I'm going to subtract something from both sides. Now I'm trying to get x all by itself. So I have this plus 6. So what do I have to subtract in order to get rid of 6? Well, I'm trying to get it to be 0, so I need to subtract 6. 6 minus 6 is 0. So whatever I do to one side, I have to do to the other side. Okay. Now I draw my line, and now I'm going to write my new equation, which would be x, well, I subtracted the 6 from 6, so I have nothing left, equals, now I have 4 minus 6. I'm going to draw this off to the side here. Following my integer operations from Unit 6, I keep the first number, change to addition, take the opposite. Now, because the signs are different, I subtract. 6 minus 4 is 2, and I have more negatives. So x equals negative 2. So now for my check, I'm going to plug my answer back into the original equation. Negative 2 plus 6 is supposed to equal 4. Well, integer rules, signs are different, so we subtract them. 6 minus 2 is 4. I have more positives, so 4 equals 4. Yes, it does work out. You have to be sure that you actually go through and solve it, that you don't just plug it in and say, oh, yep, it equals the answer. Actually check your answer to see if you did it correctly. Okay. Next one. Y plus 9 equals 22. Start with the train tracks. Now, because I have a plus 9, I need to do the opposite, which is to subtract 9 from both sides. Draw my line. My new thing will be y equal, because the 9's canceled, those subtracted from each other. Now, 22 minus 9. Make this into a 1 and 12. 12 minus 9 is 3. Bring down my 1. So then y equals 13. Let's do a check. So 13 plus 9 is supposed to equal 22. Well, 13 plus 10 would be 23 minus 1 is 22 equals 22. So, yep, it works. So then I'm going to go back, circle my solution. Y equals 13. Be careful. Y equals 13 is your answer, not the fact that 22 equals 22. Okay. Here's another one. Negative 5 equals g plus 6. Write down the equation. Make your train tracks. Since we are on the other side of the equation, that doesn't matter. We still follow the same steps. If that throws you off too much, you can always rewrite it as g plus 6 equals negative 5. But it's the same thing. So we have to get rid of this plus 6. By doing that, we subtract 6 from both sides. So they'll cancel, and we're left with g equals, well, off to the side here, negative 5 minus 6. Integer rules, I would chop minus this, and then negative 5 plus negative 6 equals negative 11. So now, let's do our check. Negative 11 plus 6 is supposed to equal a negative 5. Let's see if that's true. We have a negative 11 plus 6. Signs are different, so we subtract. 11 minus 6 is 5, and I have more negatives, so my answer is a negative 5 equals negative 5. So yes, my answer is negative 11. Okay, now there's 3 here for you to try. Pause, try them on your own, showing work for every single problem like I've been doing, and then come back and check. First one, m plus 4 equals 15. Train tracks. Subtract 4 from both sides because we're doing the opposite of adding 4. M equals, well, 15 minus 4 is 11. Our check would be 11 plus 4 equals 15. I know 11 plus 4 is 15, so yes, that's correct. M equals 11. Now, I know some of these seem easy and you feel that you don't need to show work. However, the equations will continue to get more difficult as you go, and showing your work now sets you up so that down the line you have this ingrained in you and you know exactly what to do. And you can follow the steps showing your work and you won't lose numbers. All right, 5 plus h equals negative 7. Train tracks. Again, if it throws you off that it looks like this, you could, for addition, change it to h plus 5, but I'm just going to keep it how it is. So I have to get rid of this 5 here, and I do that by subtracting 5 from both sides. Those cancel. H equals negative 7 minus 5. Well, chop minus. Now they're both negative, so we add. 7 plus 5 is a negative 12. Let's do a check. 5 plus negative 12. Does that equal negative 7? 5 plus negative 12, signs are different, so we subtract. 12 minus 5 is 7. More negatives, so yes, it is a negative 7, therefore it's correct. Circle, h equals negative 12 is our answer. Last one here that you had to try for this part. Train tracks, subtract 4 from both sides on this one. F equals, well, negative 3 minus 4, we chop minus. So negative 3 plus negative 4 is a negative 7. Let's do our check. Does negative 7 plus 4 equal negative 3? Well, signs are different. We subtract. 7 minus 4 is 3. We do have more negatives, so yes, it is a negative 3. Our answer, F equals negative 7. If you did your check and you got a different answer back, you would then go back and check your work, and it would probably tell you that maybe your integer rules were off or you made just a simple addition or subtraction mistake. So the check is super important for this. Okay, so now we are looking at one-step subtraction equations. So I'm going to go through the first three, and then you can try the next three on your own. So we follow the same steps as we did with the addition equation. So I start with my train tracks. Now I do the inverse operation. Since we have x minus 2, the inverse of minus 2 is to add 2. And if you note, we're always working on the side with the variable. That's how we decide what we're adding or subtracting. Since the variable is on this side, we have to get rid of whatever else is on that side. So add 2 to both sides for this. X equals, since a negative 2 and a positive 2, those cancel, we're only left with x. 1 plus 2 is 3. Let's do our check. 3 minus 2. Well, yes, that equals 1, so we're good. Our answer is x equals 3. Y minus 3 equals 4 train tracks. Now, variable is on this side, so that's the side that we're going to be working with. So we have to get rid of that minus 3. We do that by adding 3 to both sides. So then y equals 4 plus 3 equals 7. Now we do our check. 7 minus 3, does that equal 4? Well, 7 minus 3 is 4, yes. Okay, so our answer is correct. Train tracks. Now the variable is on the right side, so that's the side that we are working on. So we have to get rid of that minus 6. We do that by adding 6 to both sides. Now we have a negative adding a positive, so I'm going to write it out this way, horizontally, so it kind of makes more sense to me. I've got a negative and a positive, so I'm going to be subtracting, and 8 minus 6 is 2. I have more negatives than positives, so it's a negative 2. Let's do a check. So now if I plug my answer back in, negative 2 minus 6, well, I need to chop minus. Negative 2 plus negative 6 is negative 8. So yes, it is correct. Here's my answer. Okay. Next three, pause, try them on your own, and then come back and check your work. First one, m minus 7 equals negative 12. Train tracks. Since our variable is on that side, that's the side that we are working on. We have to get rid of the minus 7 by adding 7 to both sides. So then m equals, well, negative 12 plus 7. Signs are different, so we subtract. 12 minus 7 equals 5. So our answer will be negative since we have more negatives. Plug our answer in here to check. Negative 5 minus 7. Chop minus. So now they're both negative. We add negative 12 equals negative 12. Yes. So our answer is negative 5. Just know for this unit we are not using calculators, so we're going to keep practicing those integer rules from last unit. Next one, train tracks. We're on this side of the equation, adding 6 to both sides. So we have negative 5 plus 6. Okay, h equals negative and a positive subtract. We get 1, more positive, so our answer is a positive. Let's do our check. Plug 1 in, 1 minus 6. So we would chop minus 1 plus a negative 6. I'm trying to figure out if this equals negative 5. Signs are different, so we subtract. 6 minus 1 is 5. We have more negatives, so our answer is negative. So h equals 1. Last one, negative 18 equals f minus 4. Train tracks. Adding 4 on both sides. F equals, so I've got negative 18 plus 4. Signs are different, so we need to subtract. 18 minus 4 is 14, and I have more negatives, so my answer is a negative 14. Plug this in to check your work. Negative 14 minus 4, well, I would need to chop minus, make it an addition, change the sign of the second number to be a negative. So then negative 14 plus negative 4, yes, that equals negative 18. So our answer, F equals negative 14. Okay, key concepts here. You should have these written down in your notebook. I will be looking for them tomorrow. The subtraction property of equality. So we need to write everything in this box down should be on your paper. Okay. If you subtract the same number from each side of an equation, the two sides remain equal. So if A equals B, so then you could take A minus C and B minus C, and it would still be the same. And we can show that here by if we have 6 equals 6, if we subtract 2 from both sides, it still remains equal. 4 still equals 4. With algebra, this is what we're using right now to solve. If we have x plus 2 equals 6, subtracting 2 from both sides still gets us the same thing. The equation is still equal. So have that written down. Also have the addition property of equality. This tells us that if you add the same number to each side of an equation, the two sides remain equal. So if A equals B, then we could take A plus C and B plus C, and we would still have the same. Shows us here with the numbers, if we add 3 to both sides, the two sides are still equal, and that can apply to our algebra solving equations. If we have x minus 2 equals 4, we add 2 to both sides, our equation is still the same. So those properties of equality are very important as we are going through and solving. So make sure you have that written down. All right, that is solving addition and subtraction equations. Make sure that if you are stuck that you go back and re-watch parts of it. Otherwise, come with questions.